Solomon from University of Michigan, who's also going to be talking about customization in terms of recommender systems. Thank you.
Okay, so I'm going to try and kind of go through this pretty fast because I'm from the Eastern time zone and it's really far past my lunchtime. So, and besides that, I have pretty much kind of one very simple point to make with this talk. But before I kind of get to that, I just kind of want to set a few basic concepts that I imagine that many people who would come to CHI are fairly familiar with, but I think it's good to sort of put them out there. Recommender systems are systems that kind of fundamentally try to solve a tailoring problem. And this means that if there's some items out in the world, so for example, movies that people might want to watch, or music to listen to, or maybe certain types of health insurance to buy, and there's different types of users, and different users have different preferences for different types of items. The goal of a recommender system is to use some type of algorithm to match items to users, to find the items that match users' preferences and then communicate that to them effectively. And there's a lot of different technical and socio-technical approaches to doing this. Recently, a lot of the HCI work on recommender systems has looked at this idea of controllability or customizability, finding ways to give users a very sort of fine-grained control over how recommender system how tailoring algorithms and recommender algorithms work. So some examples might be users may be able to give specify weightings for different attributes. So if I was a user looking for a movie and I might say, I want action movies starring Matt Damon, but I care more about getting an action movie than getting a Matt Damon movie, so I want the algorithm to put more emphasis on that. So that might be one sort of approach for controllability or customizability. But some other work has looked at different ways of like filtering the social network that recommendations come from, or providing sort of iterative critiquing of recommendations. And most of the work that's looked at these different design approaches for customization are pretty consistent in finding that users like this, that giving control and giving customization lets users improve the system and improve the recommendations, and for certain improve the overall user experience. So the design heuristic that I want to argue for is that in a recommender system that is highly customizable, the algorithm or the underlying logic or system that produces recommendations needs to be highly flexible, such that for any particular recommendation, there are multiple different ways that the system can be configured that would ultimately produce the same recommendation. So let me show what I mean a little bit. Imagine I have a recommender system that's recommending colored shapes, and if I configure it one way, it'll give me a blue triangle. I change the settings, and it would give me a red square, and change it again, and I get a green circle. What I want to argue for is simply that it's important and a good design to make systems that have many different ways that can be configured that ultimately go to a single type of recommendation. And the reason I make this argument is based on some work that I've done in customizable recommender systems. My kind of broader research agenda has more to do with the decision making that users make after seeing recommendations. And this is kind of something that I've just sort of found along the way. But what I found is that there's an important distinction between the heterogeneity that there are among users in terms of their preferences. So people are different. People want different types of items. We know that that's why we have recommender systems in the first place. But they're also different from each other in terms of how they will navigate the system and how they will try to configure and control the system to get what they want. And what I found is that those are sort of two different dimensions in which users are different from each other, and they don't always line up very well. So what I have a number of user experiments that I've done. These are experiments that I've done on Mechanical Turk with some sort of toy systems that I've developed to kind of study decision making and with recommender systems. One of the key parts of these experiments is that I don't have users come and make and use recommender systems for themselves. I assign them their preferences. I tell them what kind of recommendations they're trying to get from the system, and that way, the sample of users who participate in these studies all want the same thing. So these are all users trying to get the exact same type of recommendation from a system. So I have this kind of homogeneous user set. And what I find is, in spite of that, all these users kind of wanting to get the same type of recommendations in terms of like the same specific items, that users will go about configuring it in a lot of different ways. So two systems that I'll kind of talk about really briefly: a system that makes recommendations for travel destinations, and another one for making recommendations about physical exercise, what kind of activity would be a good exercise for a given situation. In the study with a travel recommender, I gave users a persona, a very detailed explanation of a person. They were supposed to act like they were a travel agent for a person to find him a good to plan a good vacation, and they were given a lot of details about this persona's preferences, and they could configure this system. There are a number of different attributes that they can move sliders to kind of fine-tune how the algorithm would work to produce the recommendations. But they were all these users, again, were working for the same persona, so they really were trying to get the same, essentially, recommendation. But of 375 people who did this, I did a cluster analysis. I kind of looked at, kind of tried to cluster different combinations of where people put the sliders and the options that they chose. And it was pretty easy to make a lot of clusters. Basically, so this chart shows kind of how much within cluster variance gets reduced each time you add a new cluster. And you can kind of see it doesn't flatten out until about 30, meaning you can keep kind of dividing the groups up even more because there's more variance to be reduced. And 30 is a lot, given that, again, these sort of in theory were supposed to all be the same user, right? They're all supposed to be looking for the same thing. This is just kind of some distributions of where left or right that people move the sliders, and some other analysis. There's also a large number of different combinations for the different sliders. So for the exercise study, I did this a little bit differently, where I gave much more explicit preferences. They were kind of incentivized to find exercises that had specific features, like they were told if you find exercises that are classified as high cardio or that can be done individual or without a partner, then you'll get more points. And they were kind of incentivized to find these specific kind of exercises. And again, I should say that in this study, each user had about 100 users, and each user did this 10 different times with sort of different profiles. And I looked at, for each of these different profiles, how users configured the system. And this is an example of kind of what I found. This is a sort of prototypical example of, you can look at this, you can see there's sort of one large cluster of these users all configured the system approximately the same way. And then there's, two or three, depending on the specific profile, there's usually two or three additional sort of clusters. And in all these clusters, the large cluster never accounted for more than about 40 or 50% of all the users, which means even sort of the most popular way of configuring a system isn't even going to get half of the users who all want the same thing, right? And so that's just to kind of, actually I'm going to just go through that. And that's essentially the basis for why I'm arguing for this heuristic, that users, even when they want the same thing, they're going to try to go about it in different ways, and that two users who maybe configure a recommender system the same way, it doesn't actually mean that they're looking for the same item. So there's a danger in looking at a large set of users who have behaved the same way on a when using a kind of an intelligent system like a recommender system and saying these users are trying to do the same thing. And conversely, users who behave differently may actually have the same goal. And that's why I think it's important to look for sort of ways to make these systems flexible so that you can find lots of different ways to, so users who kind of bring their own unique mental models, unique experiences with these systems can kind of navigate and find their own way to tailor the recommender system. And I'll just kind of finish by acknowledging some colleagues who've provided a lot of feedback on this, and I'll stop there.
Thank you. I know everybody's probably desperate for lunch, but I think it'd be good to have a couple of questions. So we have plenty of time, just about. Brought us back on time, so that's good. Thank you. Just say who you are and what your question is.
Hi, Alvin from Ericsson Research. Just a question about the research in general. You call this a recommender system, but wouldn't it be more accurate to call it a faceted search system?
No. So that is a good question. So, well, the travel agent one had kind of a combination. So faceted search would be something that, yeah, I mean, there's sort of a known attribute of an item, and you can Boolean logic and filter it down. And these systems, so some of those attributes were a little bit like that, but for example, there were some that were like, weight the importance of this, weight the importance of the cost of the trip. Do you care? So they would say how much they want it to cost, but how important is it that the recommendation matches that preference?
Thank you. Okay, on that note, then I'd like to thank Jacob and the rest of the